Friends, welcome to my YouTube channel. Dhanesh here. So in the last video, we discussed about convolution layer. The convoluted neural network, it consists of 4 layers: convolution layer, activation layer or ReLU layer, max pooling layer, fully connected layer. So these are all the 4 layers a convoluted neural network is having. So in this video, I am going to discuss about the other layers, that is activation layer, max pooling layer, and fully connected layer. See, from the convolution layer, the output we got is a map. It's a, if you see the last video, you can, see it here. The output we got is a map of 7 by 7 matrix. This is the matrix, a matrix of 7 by 7. That's what we got it from the, like a 7 by 7 matrix. You got it. 1, 2, 3, 4, 5. 6, 7. 1, 2, 3, 4, 5, 6, 7. Like a 7 by 7 matrix. 3, 4. 1, 2, 3, 4, 5, 6. This is the matrix. You got it from the convolution layer. See, in this output, if you see the previous video, you can see there in this, after the convolution operation, the pixel values in this map, in this two-dimensional matrix, contains both positive and negative values. See, in this activation layer, the second, it contains positive values and negative values as well. So what is the purpose of this ReLU layer is to remove every negative value from the filtered images and replace it with zeros. So what is the purpose of the ReLU layer? ReLU stands for rectified linear unit. So you know that ReLU means rectified linear unit. This is, we call it as ReLU. ReLU, E is small letter. See, it is an activation function. ReLU is an activation function. Activation function determines whether a particular neuron or a node should be activated or not. It determines the state of a neuron, and it introduces non-linearity in the neural network. You know about that. Now, in this case, our ReLU function, this rectified linear unit, what exactly it is doing is it removes all ReLU, it removes every negative value, it removes all negative values, it is removing all negative values and replaces it with 0. So that's what the ReLU in this convoluted neural network do. So ReLU function, if I can give you some more clarity on ReLU function, ReLU activation function, it only activates a node if the input is above certain quantity. That's what a rectified linear unit does. It only activates a function if the input is above certain quantity. If the input is below 0, the output is 0. So our requirement meets here. See, the ReLU function activates a node if the input is above certain quantity. If the input is below 0, the output is 0. When the input rises above certain threshold, it has a linear relationship with the dependent variable. So that's what ReLU function does. If you see here, the ReLU function, this is the mathematical representation of the ReLU function. You can write it here like this: fx is equal to 0 if x is less than 0. Fx is 0 if x is less than 0. And fx is equal to x if x greater than or equal to 0. From this, you can understand it removes all negative values and it replaces it with zeros. So our requirement meets. And if you plot a graph of a ReLU function, it will look like this. So you can see here, if you plot a graph of ReLU function, so here this is the graph of a ReLU function. It would be like this. I know here in the if x is less than 0, y is equal to 0, and if x is greater than 0, there is a linear relationship. Here it is x and here it is y. So y means f of x. So this is the graphical representation of ReLU function. So once our output, see, we have we used in the previous video I used three kernels or filters. So filters, you can call it as kernels as well. So I will tell you filters or kernels. So that's what we used. That is the small pieces or small patches of image, and that we will slide it across the image. Those small patches, we call it as filters or kernels. So after the convolution operation, we got three maps because we used three filters. Even at that time I told you can use any number of filters. So we used three filters and we come up with three maps, and all those maps were 7 by 7 matrices. So when we apply the ReLU operation, what exactly happens here is I can tell you here. It is it's a simple operation. For example, your map, let's assume that our map is a smaller one. We got at that time 7 by 7. Here I am taking a 3 by 3 one. It's our output is 3 by 3. Even I have given an equation for the output. The output what is the size of the output. It is represented by the equation n minus f plus 1. N is the image size, f is the kernel size, and plus 1. So this equation we discussed at that time, you remember that. So let's assume that this is the map obtained from the first kernel, first filter. So let's see, this is like let's assume that this is 0.5, this is minus 1, this is 1.00, this is 0.75, this is again you can take it as minus 0.3, this is 1.2, this is 3, this is minus 1.1, this is 0.5. So what would be the output after the ReLU operations? So we are doing a ReLU, we are doing a ReLU operation here. So after the activation function ReLU, see, once it is done with the ReLU, what will happen? It will replace all the negative values with 0. So the map should be like this. Your map is like this. This is your output after the second layer. So the 0.5, it remains same. So the minus 1 should be replaced with 0. 1.20, it remains same. 0.75, it remains same. Minus 0.3 replaced with 0. 1.2 remains same. Here 3, it remains same. 0.5 remains same. Minus 1.1 should be replaced with 0. This is what happens after the the ReLU operation. The same thing is repeated for for three kernels. We used three filters or three kernels. The same operation is repeated for all the maps, because we got in the first convolution operation we got the output as 3 7 by 7 maps, based on the formula, n minus f plus 1. So this is the number of, the size of the image, input image. Here f is the size of the kernel or filter, and 1, n minus f plus 1. We discussed this formula as well in the previous video. Now I am going to discuss about the max pooling layer. So next layer, we covered the convoluted convolution operation, we covered the ReLU operation. Now we are going to discuss about the max pooling operation. So what exactly is happening in max pooling? So next layer is max pooling operation. So max pooling layer, this is what we are going to discuss. So what is max pooling layer? See, pooling, it is, if you discuss about pooling is of three types. One is pooling, it is of three types. One is max pooling is there. Next one is min pooling is there. Then average pooling is also there. I will tell you what exactly is pooling. So you have max pooling, you have min pooling, you have average pooling. See, pooling layers are used to reduce overfitting. So what is the use of pooling layers in convoluted neural network? It reduces overfitting. This is the use of pooling layer. So in pooling layer, we shrink the image stack into a smaller size. That's what we do. So in a pooling layer, we shrink the image size into a, image stack into a, we are doing the shrinking of the, output, whatever we got from the ReLU operation, we are shrinking. So we shrink the image stack into a smaller size. So that's what we do here. For shrinking this, the output, whatever we got from the ReLU operation. See, after the ReLU operation, there is no negative values. All the negative values are replaced with zeros. So in pooling layer, we shrink this image stack by using, here also we use a filter or kernel. The filter, we call it as the max pooling filter. See, the filter we use here, it is a max pooling filter. This is the filter we use here. By using a max pooling filter, normally the size of the max pooling filter, we take it as 2 by 2 or 3 by 3. This is the size of the max pooling filter. See, and we take a stride of 2. The stride we are taking here, it is 2. Stride means jump. When we discuss about the convolution operation, the filter has to jump. There we have taken a stride of 1. So that's why if the formula we got it is, n minus f plus 1. But if we are considering the stride as well or padding, this formula will be modified. We will discuss this later. So here the stride, we are taking it as 2. So then we will move this max pooling filter in our across our filtered image, and after that from each window we take the maximum intensity or the maximum value from each window. So what we are going to do, I will explain. So here we consider a max pooling filter of size 2 by 2 and the stride is 2, and we are moving this max pooling filter across the map after we got it from the ReLU operation, and we take the maximum intensity value or maximum pixel value from that. So I will explain you what exactly it is. So this is the, let us assume that this is the output you got it from the, this is a 7 by 7 map I am going to draw here. 1 2, 3, 4, 5, 6, 7. This is a 7. 1, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this map doesn't contain any negative value. You have only positive value. So this contains, let's assume that the values are 0 0.7, 1 or 2 or 3 like this, or 0 0.5, 6 or 1. Like this you are having values. See, let's assume some random values I am taking here, or you can take it like this, 1 and 0 0.2, all are positive, and 0, 1, the negative values we removed by the ReLU operation. So this is some random values, some arbitrary values I have taken. So what exactly I am trying to explain here, what is the max pooling filter do? So here the max pooling filter, what it is doing here, it is our max pooling filter is of, I am taking it as a size of 2 by 2 and a stride of 2. So here the size of the filter is 2 by 2 and stride is 2. The jump is 2. Usually we take the stride as 2. So 2 by 2 means our max pooling filter will be like this. This is our first, we place like this. This is our max pooling filter. So what is the maximum value from this? See, in this max pooling filter, when you see here, you have 4 values: 0 0.7, 1, 0 0.5 and 6. What is the maximum value here? It is 6. So what you can do, the operation is, you will create a map. Again, you are shrinking the value. See, from this 4 values, 4 pixel values, we are taking only 1. So we are again shrinking. So from this I will take 6. You will take 6 here. Again I will move. So I am taking a stride of 2. So this again it will move to the next position. So the next position should be like this. This is the next position because it's a stride of 2. So from this also I can take the maximum value, that is 3. See, that is 3 means here 2, 3, 1, 1, that is 3. Again I am moving, taking a stride of 2. So it will come to the next position. The next position is this. So let us assume some values: 1, 2, 3, 4. What is the maximum value? 4 here. So I have got 4 here. I put 4. Again I have to move. See, I need one more row and column here. I put it like this. So again I am moving. See, here I am putting some values here as well. Let us assume that this is 1 and 2. Then my filter will be like this. Here my filter will be like this. So this is the filter. So it is here, it would be like this. So here no value. So from this I have 1 and 2. I can take 2. This is the way. So I am taking a stride of 2. In the same way, when it moves down as well, I have to take a stride of 2. So the next position will be here. It would be like this. So this is the jump, next jump, it will come like here. So here I will take 1, 2, these values. Then which is the maximum in this position? This is also in the downward also we are taking a stride of 2. 1, 2. After 2 jump it came here. Then the maximum value is 2. I put it here. Then the next step, I will jump to this location, the position of the map, the max pooling kernel should be this. So from this also I will take a 1, 2 means the maximum value is 2. Like this I am shrinking the input image to a smaller size. After that I may be getting a 1, 2, 3. It would be I believe it would be 1, 2, 3 or 4. It would be a 4 by 4 size. The size of the output will be 4 by 4. So I am shrinking the input image to again by the max pooling filter. So why it is max pooling? I told there are three types of pooling. One is max pooling, the second one is min pooling, and the third one is average pooling. In this four values here, in the first case I have taken the maximum value, so this case we call it as the max pooling. If you are taking the minimum intensity value, that is 0.5, then it is min pooling, and if you are taking the average value from these four, then it is the average pooling. So it depends on your requirement. You can take whether it is max pooling or min pooling or average pooling. So this is what exactly happens in the max pooling layer. So we covered convolution layer, we covered the ReLU layer or the activation layer, we covered the max pooling layer. So the next layer, that is the fully connected layer, will be discussing in the next video. So thanks for watching.